Hi, in this video we'll do a couple of examples dealing with compound interest, and here we're going to assume that our interest is compounding continuously. We're going to use the formula that the amount we have after t years is going to be equal to the principal times e, that representing Euler's number, to the RT power. I like to say A is equal to PERT. There we go. That's how I remember it. All right, so in these two different problems, we have different inputs. We know in the first one, the initial investment and the annual rate. And what we want to determine is the time to double and the amount that we'd have after 10 years. Okay? All right, so we know the amount that we'd actually have if it doubles. So we're going to look at this one first. So we know we'd have, if $4,000 doubles, we'll have $8,000. That's going to be equal to 4,000, all right, because that's our initial investment, that is P, and then E to the R, which we know to be 0.06. Remember, you're going to use the decimal representation of your rate here. So if it's 6%, we got to move the decimal 2 places, 0.06, and then we have T, and that is what we're looking for. So to begin with, we would divide each side by the 4,000, okay? And obviously we would get 2, and that's going to be equal to E to the 0.06 to the T. And now in order to get rid of the E, we're going to take the natural log of both sides. Okay. On the left-hand side, we're left with the natural log of 2. And on the right-hand side, the natural log and the E cancel out, and I'm left with 0.06 T. And now dividing both sides by 0.06, I get that T is equal to natural log 2 divided by 0.06, which is approximately 11.55 years. Sorry about that. Okay, so we're going to plug that in here. And now if we want to know the amount that we would have after 10 years, all right, that's just going to be A equal to our principal, which is 4,000. Okay, E to the R, which is 0.06. And our time in this case is going to be 10. Plugging all that into our calculator, we would get 7,288 and 48 cents after 10 years. It's not quite double. Okay, so again, make sure you can plug this into your calculator and get this number. All right, let's look at our second problem. All right, and now we know it takes 5 years for it to double. We're starting with 12,500. So again, we're going to set this up similar to the one before. If it doubles, we have 25,000. We know that's equal to 12,500 because that's our initial. E to the R we don't know, but now in this case we know the time is 5. So similarly, we divide both sides by 12,500 and we get 2 equal to E to the R to the 5R. Okay, again taking the natural log of both sides in order to get rid of our exponential. I'd get the natural log of 2. All right, over here natural log and E would go away and I'd just be left with 5R. Dividing both sides by 5, I get that my rate is equal to natural log 2 over 5, or approximately 13.86%. I wish. All right. Haven't seen those in a long time. But now if we want to know the amount after 10 years, again, we're just going to use our original formula, the amount. Start with our principal, which is 12,500. E to the rate now. Again, remember you got to convert a percent to a decimal, so that's going to be 0.1386. And now we know our years as 10. That's given up here, 10 years. Okay, plugging all that into my calculator, I get right on the money of $50,000. That would be a nice investment. So those are some applications of our continuously compounded interest.